Okay, so hi everyone, I'm Alireza, and today I will be focusing on Russell's human knowledge, its scope and limits, and I found some interesting stuff about the science of mind. So today I will go through this topic by explaining perception, language and communication, and probability theory, and how these are connected to our topic of discussion today. So first, to start things off, we have to look at psychology. To analyze perception, we must first define psychology. So Russell's definition is the science of those occurrences which by their very nature can only be observed by one person. However, if we look at our textbooks in psychology that we're studying at university, the definition is the scientific study of the human mind and its functions, especially to those affecting behavior in a given context. Russell has explained human perception in two ways. Private, which is each person's personal space and the things that goes on in his mind. And the public, which is the collective thoughts in a group of people. It is believed that one's private space is always different from the public, but this could be disproved by bringing time into consideration. Suppose you are at a football game and you have witnessed a goal. Then if you take a small interval of time, let's say 5 seconds at that moment, more or less the public space will be similar to that of the private space. This space is called the data of psychology, and therefore the public data during certain moments, private data during certain moments will be the same as that of the public. So which one do you think is more important, the public or the private? Well, the matter of fact is that none of them are more significant than the other. But private data is essential for us to make a decision on facts. Private data should be used because individual perception is different from that of the public reflection. And since we do not necessarily share a common need with that of the public measures, it is critical to always have a sense of what something means to me, rather than judging it by the public data available to us. So, the public data controls our mind. Well, since people tend to rely heavily on public data, there are ways which our mind could be easily controlled with some simple techniques. Those who wish to do this use a simple formula consisting of habit, pride, self-interest, and change our beliefs with this way. By frequently repeating these three areas mentioned, we will depend on our comfort zone and automatically trust the data that is repeated to us. In our modern time, this is seen through advertising, and it's evident that certain quotes that we hear never escape our mind. These could include free stuff feels good, or methods used to make you think that some products are healthy. Once they know your weaknesses, then they directly attack those three areas mentioned and frequently make you see them on the internet, radio, TV, for you to want their products. Moving on to the next part of the topic, I will discuss language with you. And language could be anything from art to music, to paintings, letters, newspapers, photos, and everything else in between. Ostensive language is any process by which a person is taught to understand a word otherwise than that by the use of other words. This process involves pointing at things to get the message across. Russell mentions that we cannot learn all our language without the use of ostensive means and assign words for certain objects. These objects could be animals, colors, up, down, or even bread. So then after we get into Carnap's theory of space-time. This focuses on reducing spatial topology to temporal order and causal order. We have four dimensionals here, with the consideration of time, which measures the mark of the path of a person from birth to death. Temporal order is when we put the location of things with respect to time. So, using this method, we must be sure to consider the curvature of the Earth for further accuracy. So, for example, if people travel from one place to the other, this distance traveled is put with respect to time. However, the causal order refers to the order with respect to each event rather than the timeline. So, the distance traveled will be mapped regardless of how many times I have been at the same location. The point of bringing this space-time relation into our use of language is to minimize our use of proper names. Russell argues that this is achievable in terms of reusing proper names associated with theoretical physics, but no parts of history or geography could be reduced using this method. The advantage that comes with minimizing our vocabulary is seen through higher accuracy and more effective communication. To Russell, this happens if communication contains no words in which is capable of a verbal definition in terms of the other words of the vocabulary. Egocentric particulars. These could be thought of as equations used in sentences. The equation has 4 variables, and 3 of these become constant automatically by when somebody uses them. So the four variables are I, here, and now. And the 4th one is the word this. And these constants are filled in automatically. So for example, if I'm standing here and I tell you that I, Alireza Zamani, am at McMaster University at 2 o'clock, then these 3 are automatically filled in based on the location I'm at, and the person I am, and the time. However, there is a 4th component to this, and that is the word this, as I mentioned to you before. Because this can be any object, it is not unique to me or the space-time position I am in. In fact, 2 different people can refer to the same this, and this is why this word is not a constant and is a variable. To properly eliminate these ambiguities, Russell gives an example where 2 people are in a dark space and they cannot find each other. So one of them says, "Where are you?" And he says, "Here I am," but you can actually see each other, so you can never know where the other person is. But if you actually define that at certain time, at 11:32 p.m. on January 1946, I am at latitude 4 and longitude 29 west, then you can definitely find the person. It's very logical. So then we get into Leibniz monadology. Actually, I really like this theory. Here we get introduced to this theory, which is the simplest form of all substances. This means that these substances cannot be broken down into smaller particles, and they are the building blocks of all complex material. Since there is no building block to build monads, they cannot be created or destroyed as well. However, monads are all unique and have different characteristics. This is true since no 2 things are perfectly identical in nature. So even though these monads are the most simplest forms, but they are all different than each other. Monads are thought of as consciousness without memory. Basically, everything is made up of monads, and there is no empty space in the universe that lacks this material. Monads are all independent of each other, and they do have a consciousness. Also, the changes in their character are not decided by themselves, since there is no logical thinking involved for the monads to decide how to perceive things. But the surrounding environment that they are in will cause their characteristics to change. A change in the character of a monad is seen when a living being dies. That means that the monads that create the living things have changed characteristics to monads similar to a non-living object such as a rock or soil. This makes us seem like energies, and through this medium we are all communicating. All the movements of our muscles are reacting against positive and negative energies of our surrounding, which are basically goes down to the monads that build us. The next part of the presentation is probability theory. So Russell always explains everything with axioms when he's talking about mathematics. So the axioms of probability are that any given probability is always between 0 to 1, and 1 being 100% accurate, 0 being 0% accurate. If two independent probabilities, you can add them if they are mutually exclusive by the summation of their probability. So I'm just going to go through a very simple example where a problem could fall into this category, and that is when you have a bowl of urns and there are 10 of them in there, and 6 are red, 4 black. So if you want to calculate the probability of picking a red urn, then it's 6 over 10, simply said. Next we get to Bayes' theorem. Bayes' theorem is very interesting because even though we have certain probabilities, we can use some other given information to see how that affects the initial probability that we were calculating. This is basically a way for us to have more information and evidence to use and see if the initial event's probability will increase or decrease based on the information that we have attained. So this technique is extremely useful in our life to take advantage of the information that we have instead of not using it in our decision making. An example is when you want to calculate the probability of having a jack from a deck of cards. Then that is simply, since there's 4 jacks in the deck of cards, that would be 4 over 52. But if you were given that the next card picked will be a face card, then that changes everything. And since there's only 12 of them, the probability would be 4 out of 12. So that very reduces the probability. Next law we're going to look at is Bernoulli's law of large numbers. We all know that if we repeat an experiment an infinite amount of times, we will have a very accurate estimate of the average. This is only possible if these experiments are independent of one another and totally random. Suppose, for instance, we are tossing a coin. If we do this experiment 3 times, and maybe all the outcomes will be tails, then we can conclude that any time you flip this coin, it will always result in getting a tail. But if you take this law into consideration and repeat this infinite amount of times, you will see that the probability will be reduced to 50%. This principle is not only designed for problems such as flipping coins, but however it can be applied to any unknown probability in our society or economy for us to realize the outcome of these problems, in our society or economy for us to realize the outcome of these problems will approach by taking large sample of independent instances. So let's say you have an economical issue, you make samples of certain events and you record all the outcomes of these individual samples, then you can get a very general idea of what the outcome of that event could be. In fact, Bernoulli's objective was to show us a new way of approaching legal issues using probability theory. Other examples that are successfully seen from these results are insurance companies. In insurance companies, simply make unknown outcomes more probable by combining n number of uncorrelated risks into one single portfolio. So as the n amount of portfolios increases, it is easier for them to spot the most probable outcome, and they will all bet everything on that. The way that this industry works is sufficiently reducing the probability of total claims to exceed the threshold, which is this formula, the mean plus epsilon, which is a very small value times the number of portfolios that you have. And this principle, and by increasing the size of n, you are decreasing your epsilon, which ensures a high probability that the total claims that people can get from you is lower than this threshold. Next, we are going to analyze Russell's principle of induction. This principle also, the foundations of this principle is also laid on Bernoulli's law of large numbers. But this principle explains as the number of cases that event A is linked to event B increases and the number of cases where they are not linked shrinks, then we are more and more confident that to conclude that these events are correlated. The principle of induction is not designed for practical use. Even if you disprove this principle by personal experience and witness an instance where event A and B are not happening at the same time, we cannot disprove it. The principle is the foundation of science, and Russell believes the principle of induction should only be acknowledged on the grounds of its intrinsic evidence. To conclude my presentation, I would like to share with you some of the stuff that I learned through this course. Very interesting. I picked 3 of the most interesting things that I learned. The first one is that the universe is moving towards disorder. This means that even if you go clean your room right now, it's going to be messier tomorrow. You don't touch anything. Everything goes towards disorder. So this could be seen in soil erosion happening everywhere. And for example, if the sun explodes, then the energy which is concentrated in that area would be distributed everywhere. And everything is going towards equilibrium. And the second one is that the universe does not get surprised by probability. So for example, if you have a winning lottery ticket number, always people are fascinated by that number, the winning number. But in fact, the number that I was holding had the same probability of winning as the winning number. So this is no surprise to the universe, but it's just in the human psychology that we are so surprised. The last thing was this statement here, which was really the most interesting one that I found, and that is just looking at things and how everything in the world is probability. This says everything that we see is nothing but a distribution of probabilities. We do not see what is there, but only what is more or less likely to be there. And we see it just as much when it is not there as when it is there, provided that the probability is right. So that concludes my presentation.
Thanks a lot, Ali. Do you have a question for Ali? Quick question right here. Yeah, thanks. Quick question at the back, yeah?
Yeah, so in the beginning of the presentation, you mentioned that there was public perception and private perception. And there's really no importance one or the other. They're in that sense equal. So my question is, if you're talking about probability and that anything and can be, there's no surprise in the universe because it's all really an aspect of probability. Wouldn't public perception therefore have more significance than private perception? That is what drives the probability of social situations?
Well, that is true because the public space is actually could be related to Bernoulli's law of large numbers. So once you take so many different private data, you will eventually have a public sample of data, and that could represent every single private data that is there. So again.
So my second question to that is, understanding that notion that you just said right there, could we in essence somehow predict the outcome of certain conflicts? So like if a war is one like is being waged, could we somehow like predict the outcome?
Yes, that's basically taking samples. So if you create wars, you will have samples of the event of a war, and you can see that throughout human history. There has been many of them, and the outcomes are very clear to us. So if you have another war tomorrow, the outcomes will probably fall within one of the other ones. So does that answer your question?
Yeah, thank you very much.
Thank you. Thank you, Alan.